Hello, you gorgeously wonderful humans. Let's go through today's lesson, which is going over 8.11b. It is a supporting standard, so hopefully you won't be tested a heck of a lot on it, considering it is kind of a more grueling concept. Doesn't mean it's hard. It is not difficult. There's just a lot involved. And as long as you're taking good notes, you can always use them on every assessment until you have this thing memorized. So let's go through it. 8.11b. Determine the mean absolute deviation and use this quantity as a measure of the average distant data, are from the mean using a data set of no more than 10 data points. What that means is we're going to use average to see if a set of data is valid. So the bigger my mean absolute deviation is, the less validity my data set has, which we'll get into that. The vocab we're using today is number 5, mean absolute deviation. Stands for MAD, is the average distance between each data value and the mean. The mean means average, which I did put the formula on there. We're going to add all the values together and then divide by the number of values. Cool. Once you're caught up, go ahead and flip to page 5. Our last page in the notes for this unit. Well, unit 6, but we've combined unit 6 and 7. So in any case, our essential question is, what is MAD and how do you determine the mean absolute deviation of a data set? So first, let's go through what mean absolute deviation is. Mean is the mean or average of the set of data. Absolute is the absolute value. Which is how far a number is from 0. Just keep in mind that this is always positive. Always, always, always. We like to keep things positive in here. Deviation is the distance. How far does it deviate? Cool. So MAD, mean absolute deviation. I do like to say MAD instead. It is a heck of a lot shorter and easier to say. MAD is the mean of the distance between each data point and the mean of the data set. What does this mean? Basically, it means you're going to find the average twice. We're going to go through it once, find the average. Then we're going to go through it again, and find the average yet again. But it is just really 3 simple steps. So let's not get too freaked out. Step 1. Find the mean, which we're gonna do. How do we find the mean? We add all values together and then we divide by how many values there are. All right, I like to put my data sets in chronological order. I feel like it makes my brain happier and it makes me just feel a little bit more organized. So we're gonna start with that. We have 2 6s, 7, 8, 11, 15, 16. Cool. Did that. Now I'm going to add them all together. Then divide by how many I'm adding. So 3 plus 6 plus 6 plus 7 plus 8 plus 11 plus 15 plus 16. All divided by how many there are. And there's 8 total values. I already previously added these, and yes, I can add them mentally. You have a calculator. Just go ahead and type it in, get your answer, which you should know is 72. Then we're doing 72 divided by 8, which equals 9. So my average is 9. The average number out of the entire data set of 8 values is 9. So now, second step is find the distance of each value from the average. We are going to keep things positive by finding the absolute value, which means if things ever came out to a negative, we're just going to say it's positive. So X is our original data set, 3, 6, 6, 7, 8, 11, 15, 16. This really weird, I think it's umlaut. No, I'm wrong. I don't know what the symbol is. I will know. I'll find that out. But we are subtracting. So 3 minus 9, because 9 is our average. 6 minus 9. 6 minus 9. 7 minus 9. 8 minus 9. 11 minus 9. 15 minus 9, and 16 minus 9. Again, you have a calculator. Use it if you don't like to do mental math, and if you think adding and subtracting simple numbers is difficult for you. But it also is a good chance to work on those things, I feel like. 3 minus 9 is 6. Sorry, 3 minus 9 is negative 6, but we're taking the absolute value, which is 6, because negative 6 is 6 units from 0. 6 minus 9 is negative 3. 7 minus 9 is negative 2. 8 minus 9 is negative 1. 11 minus 9 is positive 2. 15 minus 9 is 6. And 16 minus 9 is 7. Boom. Cool. Done. Step 3. We're going to find the average. Find the mean of the distance found in step 2. So once again, we are going to add all the values together and divide by how many values we're adding, which we know to be 8. So once again, I like to put things in chronological order. I feel weird if they're not, so I'm going to do that. 1, and then I have 2 2s, 3 3s, 2 6s, and 1 7. So let's add it up. 1 plus 2 plus 2 plus 3 plus 3 plus 6 plus 6 plus 7, all divided by 8. When you add them all up, you get 30. 30 divided by 8 is 15 divided by 4. And 4 can go into 15 3 times. Remainder 3, which I know to be 3.75. But of course, in your calculator, you just did 30 divided by 8 and got 3.75 automatically. So the mean absolute deviation is 3.75. I would say that this is a relatively valid set of data, considering it is not greater than 5. We really like to keep the mean absolute deviation less than 1, because the closer to 0, the more groupings and together my data points are. But yeah, and the bigger the MAD, the less valid. The more spread out my data is. The smaller the MAD is, the more close together it is. All right, let's do one more. So I have this dot plot right here, down here. And the first thing we're gonna do is pull off all the data points. So 0, 1, 2, and then 3 7s. Cool, let's add them all up and then divide by how many we're adding. 0 plus 1 plus 2 plus 7 plus 7 plus 7 divided by 6, which comes out to 24. Divided by 6, which is 4. And now I'm going to subtract. I'm going to use a different color just because I'm starting to get a little smushed here. So 0 minus 4, 1 minus 4, 2 minus 4, 7 minus 4, 3 times, which equals, again, absolute value. So even though 0 minus 4 is negative 4, we're just going to put 4. 3, 2, and then 3 3s. Now I'm going to add all those values together and still divide by 6. So 4 plus 3 plus 2 plus 9, right? Because 3 3s is 9. Divided by 6. When you add all that up, it equals 18. And 18 divided by 3 equals, sorry, 18 divided by 6 equals 3. So my mean absolute deviation is 3 for this lovely dot plot. And again, what that means is our data is slightly spread out, considering it is 3 units away from 0. And when it comes to MAD, we really do want it closer to 0. It just shows the closer my data sets are. But of course, this is all a very statistical concept. Yeah, I'm just going to stop talking. Hopefully you guys understand it. If you don't, please refer back to your notes. That's why we take them.